Hello guys, and welcome back to another episode on chemistry, your favorite subject. All right, and today we are going to learn how to assign what oxidation what number. Okay, so basically it is important to know that assigning oxidation number to a species is governed by a set of rules. You don't just assign oxidation number anyhow. There are rules that are governing how to assign oxidation number to species, and that is what we're going to be looking at today. How to assign oxidation number. All right. So please note that this video tutorial, of course, is brought to you by the one and only best CBT practice app, the O3Schools JAMB CBT practice app. It is all you need to succeed truly in your exam. It has wonderful features such as one, the classroom feature, where you can be taught, where when you are trying to decipher answer to a question, there's a chat bot there that you can ask questions that are relating to what you are trying to decipher, and to keep on explaining to you until you get the right answer. Wonderful study mechanism. You do not need any human being there. Just chat with the chatbot, and it will help you. The classroom feature is a wonderful feature. Also have the question search feature, where you can search for questions by topic. All right. Also, we have so many modes on the app. There's a study mode, there's a practice mode, right? There's a mock mode, there's an exam mode. So you can take so many number of mocks, right, on the app before your main JAMB exam. Isn't that wonderful? Also, we have another wonderful feature we call the UTME challenge. It's a challenge that we conduct for all students that are writing JAMB each year. All right. So we conduct that challenge every Saturday till 1 week to your JAMB exam. And after the challenge, after every week's challenge, we release your result to you according to the number of subjects you have written, right? And once we do, you are going to be able to see your weak points, like the areas you need to improve upon. You're going to see the areas that where your strength lies. All right. And the more you participate, you are going to win prizes while you are participating. That's one part of it. And also there are other wonderful things that you can gain from it. Like one, you can get used to how JAMB set that question. Isn't that lovely? Then also to build your confidence towards the exam. So what are you waiting for? Head to Play Store right now, download the app. The app is also available for your computer, your laptops, and your tabs. So in case you want to download for your computer, just send a message on WhatsApp on this number 09121515246. Just send a WhatsApp message to this number. Just say, please, I need the link to download the laptop version or the computer version for your app. Right? The app is available for Android devices. It's also available for iOS very, very soon. All right. Activation of the app is just 3,000 naira as at the time of shooting this video. The price may increase, but it's 3,000 naira as at the time of shooting of this video. So please, in case you want to activate your app, also message this number on WhatsApp. All right. And of course, there's no need thinking it's a scam. It can never be scam. All right. So please pay for your activation, and you will get it done immediately. All right. So that is that for that. Now let's look at how to assign oxidation number. How to assign oxidation number. And I've told you that when we are talking about assigning oxidation number, there are some set of rules that govern how to assign this oxidation number. And these are the rules we are going to look at. So we're going to look at rules of assigning oxidation number. Number one, the first rule says an element in its free state. An element that is in its free state, that is not combined with another element. All right. An element in its free state has an oxidation number of 0. All right. An element in its free state has an oxidation number of 0. Okay. I'm sure in the previous episodes we have already had an idea about elements in their free state. If this is your first episode you are watching, there are so many episodes about oxidation and reduction reaction. So please go back and watch them. Okay. Now, an element in its free state has an oxidation number of 0. For example, you have element, e.g., we have chlorine standing alone. Let's say we have bromine, we have zinc, we have sodium. All of them, they are all standing alone. the oxidation number is 0. All right, so that is the first rule. An element in its free state has an oxidation number of 0. Please like this video. Liking this video will make other students easily find this video and also watch and learn like you. It will be bad that you are the only one benefiting from this. Just click on that like button below the video right now as you are watching it. Just do that please quickly. And also do not forget to subscribe, because when you subscribe, whenever we publish a new video, you'll be notified on your phone that O3 Schools has published a new video. Isn't that wonderful? Please just click on that red subscribe button. If your own is showing red, that means you have not subscribed. If it's showing ash, it means that you have what? Subscribed. Please click on the red subscribe button immediately. And do not forget to carry this link, share the link, the video of the link to your friends, to your class group, so that they can also what? Learn and what? Pass successfully. All right. So now, that is the first rule. An element in its free state has an oxidation number of 0. E.g., if I are seeing chlorine, bromine, zinc, sodium standing alone, the oxidation number is what? Is all 0. Now, number 2 says that an uncharged compound has an oxidation number of 0. All right, an uncharged compound, a compound that does not have a charge on it, has an oxidation number of what? Of 0. This, to explain this, they are trying to say that what? The sum of all the oxidation of each of the individual what? Elements, the sum of the oxidation number of each of the individual elements in a molecule of a compound is 0. When you add all the oxidation number together, they are going to give you what? 0. Right? So that is what they're trying to what? Talk about. So an uncharged compound has an oxidation number of 0. For example, maybe you see CO2 standing alone, you see HBr standing alone without any charge on it, the oxidation number is going to be what? 0. Right? Of course, let's see example, e.g. CO2, H2O, HBr, K2CO3, all have what? Oxidation number of what? 0. All have oxidation number of 0. All right, that means that what? The sum of all the oxidation numbers, right, of elements in a molecule of a compound is 0. The sum, to explain this, the sum of all oxidation numbers of elements in a molecule of a compound is equals to what? Is 0. It's equals to 0. The total charge, the total what? Oxidation number, the sum of all the oxidation number is equals to what? 0. Now, this is the second what? This is the second what rule that guides what? How to assign oxidation number. Also, number 3. Now, a charged atom or radical, will have an oxidation number corresponding or equivalent to its charge. All right, what is a radical? You know what a radical is, right? A radical is an atom or group of atoms that possess electric charge, right? So a charged atom or radical will have an oxidation number corresponding or equivalent to what? Its charge. For example, if you have, let's say, Mg magnesium, for example, Mg2 plus, right? You know that what the charge on what magnesium is what 2 plus, a group 2 what element. So it will have an oxidation number of what? Of 2. All right. So the what oxidation number of magnesium of what will be 2. You get it, right? So that's what we're trying to say. So let's see examples. E.g., if you have, for example, e.g., if you have chlorine standing alone, right? If you have what? Mg2 plus standing alone, if you have Cr2O7, 2 minus, right? You are seeing what? A charge on it. You are seeing the charge. It's a charged atom or radical, right? If you have, for example, MnO4 minus, right? You can see that what the oxidation numbers are -1, then +2, this one -2, right? And -1 respectively. All right, so these are the oxidation numbers. So a charged atom or radical will have an oxidation number corresponding or equivalent to its charge. E.g., Cl minus, we have oxidation number of -1. Mg2 plus, we have an oxidation number of +2. CrO2O72 minus, we have an oxidation number of what? -2. And of course, MnO4 minus, we have an oxidation number of what? -1 respectively. I'm sure this is very clear. In case you do not understand any part of this, please make sure you drop a comment. Now, let's go to the fourth part. Let's go to the fourth rule, rather. The fourth rule. The fourth rule, right? Hydrogen, we're talking about hydrogen. Hydrogen has an oxidation number of +1. It has an oxidation number of what? +1 when it is combined with an element that is more electronegative than itself. All right? Hydrogen, let me put that down. That's number 4 now. Hydrogen has an oxidation number of +1 when it is combined with an element that is more electronegative than itself. All right, hydrogen has an oxidation number of +1 when it is combined with an element that is more electronegative than itself, and an oxidation number of -1 when it is combined with an element that is less electronegative than itself. That is what? Elements that are more electropositive than hydrogen. All right, I'm writing all out so that what you want to get the full story, so that you say you will not have any cause to say you don't ever understand this, right? Even if your village they say you will not know book, right? You will understand this because it's very, very easy. That's why I'm writing it out for you, right? So now, hydrogen has an oxidation number of +1 when it is combined with an element that is more electronegative than itself. That's what it's combined with an element that is more electronegative than hydrogen. Hydrogen will have what? An oxidation number of what? Of +1. All right. Now, it will have an oxidation number of -1 when it is combined with element that is less electronegative than itself. That is what? More electropositive than hydrogen. There are elements in the electrochemical series that are more electropositive than what? Than hydrogen. When hydrogen combined with those type of elements, right, you see that what? It will have an oxidation number of -1 in the compounds that it forms with them. All right. So that is what I'm trying to talk about here. That is, so let me just say IE now. That is more electropositive than hydrogen in the electrochemical series. All right. An example of such elements is sodium. Sodium, even calcium is more electropositive than what? Than hydrogen. All right, it's than hydrogen. Yeah. So that means, e.g., we're going to have let's say sodium combines with hydrogen. Sodium in sodium hydride. Example, this is an example. Hydrogen we have what? An oxidation number of -1. This kind of compound because it is combining with an element that is more electropositive than it. Okay. Another example is what? CaH2, calcium hydride. All right. These are example. etc. They will have what? In this kind of compounds, they will have hydrogen will have an oxidation number of what? Of -1. Also, hydrogen has an oxidation number number of plus 1 when it is combined with elements that are electronegative, E.g., we have, for example, we have fluorine, we have chlorine, we have nitrogen, we have what? Oxygen. All these kind of elements that are electronegative. When hydrogen combines what with them, it will have an oxidation number of what? Of plus 1. Those kind of what? Compounds. For example, in H2O, all right? In H2O, hydrogen is what? Hydrogen has was plus 1. Hydrogen fluoride, hydrogen chloride, they all have what? Hydrogen cyanide, they all have what? Oxidation number of what? Of plus 1 in those kind of what? Compounds. Are you there? So that is what the fourth rule that guides what? How to assign oxidation number. Hydrogen has an oxidation number of plus 1 when it is combined with an element that is more electronegative than itself, and an oxidation number of minus 1 when it is combined with an element that is less electronegative than itself, that is more electropositive than what? Than hydrogen. Okay, that is what? More electropositive than hydrogen in the electrochemical series. Maybe I shouldn't have written this one out again, but it's all for you to understand. Okay, so having sodium hydride here and calcium hydride, hydrogen also has an oxidation number of plus 1 when it is combined with elements that are electronegative, like fluorine, chlorine, nitrogen, and oxygen. All right, there's so many other ones, right? So that is that for hydrogen. Now we now look at what? Oxygen. Number 5, oxygen has an oxidation number of minus 2 in all of its compounds, except in peroxides, where it has an oxidation number of minus 1. I think I hinted this in the last episode, right? Oxygen has an oxidation number of minus 2 in all of its compounds except in peroxides, where it has an oxidation number of minus 1. Example of peroxides, e.g., is sodium peroxide Na2O2, is barium peroxide BaO2, is potassium peroxide K2O2, is hydrogen peroxide H2O2, etc. In all of these compounds, oxygen has an oxidation number of what? Of minus 1 instead of minus 2. So we have to what? Watch out for them, right? In peroxides, oxygen has an oxidation number of minus 1 and not minus 2. You have to take note of that very, very well. So now let's look at the halogens. That will be the last rule we are considering. The halogens. The halogens have an oxidation number of minus 1 in most of their compounds. But in interhalogen compounds, they may have what? Oxidation number that are ranging from minus 1 to plus 7. All right, let's see. That's number 6 now. 6th rule. Halogens have an oxidation number of minus 1 in most of their compounds. But in interhalogen compounds, halogens may have what? Oxidation number ranging from minus 1 to plus 7. E.g., example is what? Example, we have ClO2 and Cl2O7. In these compounds, right? And in these compounds, the oxidation numbers are plus 4 and plus 7 respectively. All right, so when we're considering our halogens, halogens, right? Those elements that are in the what? In the group 7 7A of the periodic table. Okay, so halogens have an oxidation number of -1 in most of their compounds. In interhalogen compounds, halogens may have oxidation number ranging from -1 to +7, e.g., ClO2 and Cl2O7. In these compounds, the oxidation numbers are +4 and +7. So, oxidation number of what? Of ClO2 is +4 here, of Cl here, in this compound is +4. Why? This one is what? Is plus what? 7. All right, respectively. So, that is that for that about what? How to assign oxidation number. Thank you for watching, and I'll see you in the next episode.